Welcome back to the third part of the basic statistical review. We're going to continue to talk about statistical tests. On this page, I have listed some popular statistical tests. So as you can see, the first one I'm going to talk about is the correlational statistical test. So there's two types of tests, is Pearson correlation and Spearman correlation. So what is the correlation? So basically, correlation is signal the pattern in data between variables. A positive correlation or positive association occurs if the value in one variable increase as value in another also increase. A negative association or negative correlation occurs when variable in decreasing while another variable also decreasing. The correlation coefficient expressed in R describes the strength of the relationship. A value of 0 means no relationship, and relationship strength as R approaching to 1 is positive relationship, or negative one, that is negative association. A chi-square test determines the effect of relationship between categorical variables, which determine the frequency and proportions into which those variable falls. Similarly to the other tests we just discussed, variant and the extension of chi-square tests may be suitable depends on the variables. An independent sample t-test allows a comparison of two groups of subjects on one variable. Examples in biomedical research include comparing the result of treatment and control group and compare differences based on the gender. A paired t-test is actually analyzing one sample population measuring the same variable on two different occasions. This is often useful for intervention and educational research. So let's talk about one-way ANOVA test. So ANOVA test stands for analysis of variance. So it is an extension of t-test. Determine the differences among more than two groups or independent variables based on the dependent variables. Choosing an appropriate statistical test for your study ensures that you make correct and stronger inference from the data. Use following table to guide your decision. To determine the appropriate test for your test, you need to know the very type of your predictor and outcomes. So if you look at your predictors, you have the second column, right? If it's a categorical one predictor, and if you look at your outcomes, if it's quantitative, also groups comes from the same population, then you have used pair t-test. So if your study involved with categorical one predictor, then if you look at your outcome is quantitative, but the group comes from different population, then you have to use independent t-test, and so on and so forth, right? So that's how you choose the test for your study. A post hoc test is used only after we find a statistically significant result and need to determine where our differences truly come from. The term post hoc comes from the Latin for after the event. A one-way ANOVA is used to determine whether or not there is statistically significance between the two means, or three or even more independent groups. If the overall p-value from ANOVA table is less than some significant level, then we have sufficient evidence to say that at least one of the mean of the group is different from the others. However, this doesn't tell us which groups are different from each other. So it simply just tells us that not all of the group means are equal. In order to find out exactly which group are different from the other, we must conduct a post hoc test. There are many post hoc tests that we have developed, and most of them will giving us similar answers. So I will introduce you the most popular tests briefly. You don't need to know how to perform each test, as you can request SPSS to conduct those tests for you. The first test is Tukey's test. The purpose of Tukey's test is to figure out which group in your sample differ. It uses the honest significant difference, so that is a number that represented the distance between the groups, to compare every mean with every other mean. So next, let's talk about Newman-Q's test. So like Tukey's test, right? This post hoc test identifies sample means that are different from each other. Newman-Q's use different critical value for comparing pair of means. Therefore, it's more likely to find significant difference. Lastly, let's talk about Sheffice's method. It is used when you want to look at post hoc comparison in general. Sheffice controls for the overall confidence level. It is customarily used with unequal sample sizes. Non-parametric tests are sometimes called distribution-free tests because they are based on a few assumptions. Parametric tests involve with a specific probability distribution, and the tests involve estimation of key parameter of that distribution from the sample data. The cost of fewer assumptions is that the non-parametric tests are generally less powerful than the parametric counterparts. It can sometimes be difficult to assess whether a continuous outcome follows a normal distribution, and thus whether a parametric or non-parametric is appropriate. There are several statistical tests that can be used to assess whether the data are likely from a normal distribution. So the most popular ones are Kolmogorov-Smirnov test, the Anderson-Darling test, and the Shapiro-Wilk test. Each test is essentially a goodness of fit test and compared observed data to quantiles of a normal distribution. The new hypothesis for each test is hypothesis 0. The data follows a normal distribution versus hypothesis 1. Data do not follow a normal distribution. If the test is significant difference, then the data do not follow a normal distribution, and the non-parametric test is warranted. It should be noted that the test for normality can be subjective to low power. Specifically, the test may fail to reject null hypothesis, that data follows a normal distribution. In fact, that data do not follow a normal distribution. Low power is a major issue when the sample size is small, which unfortunately is often when we wish to employ these tests. The most practical approach to assessing normality involves investigating the distributional form of the outcome. In a sample, use a histogram or argument that with data from the other studies, if available, that may indicate the likely distribution of the outcome in the population. There are some situations when it's clear that the outcome does not follow normal distribution. These include when outcome is ordinal variable or rank, or when there's definite outliers, or outcome has clear limitation of detection. This table here lists the common parametric tests that you will use in your project and corresponding non-parametric equivalent of each test. Wilcoxon rank sum test is used in place of pair t-test. Mann-Widman U-test is the non-parametric equivalent of independent t-test. Kruskal-Wallich test is the non-parametric form of ANOVA. When you have categorical variables, Spearman correlation is used to replace the Pearson correlation. I hope this review is helpful for you. If you have any question, do not hesitate to contact me. Here is my email address. Thank you for your time and attention.